more people coming in. Channels 2.0 now embraces Python's async support, building apps around an event loop rather than using worker processes. Andrew Godwin is a Django core team member and the author of Channels. He's going to share with us the motivation for that change and what's next for async in Django. Please make Andrew feel welcome.
Thank you very much. Yeah, hello, everybody. As you've just heard, I am Andrew Godwin. I am perhaps most infamous for being a Django core team member. I've worked on things like Channels and Django migrations and South back in the day. My day job is, on this slide is wrong, I'm now a principal engineer, at Eventbrite. And generally, I have a bad hobby of picking the nastiest parts of programming to do for fun. In this case, network and asynchronous programming, as we'll see in a moment. But this talk is mostly about channels, and Django and channels and how they talk to each other. Around 2015, I sort of thought of the idea of channels. I think it was around one of the Django under the hoods that year. And was like, yeah, we should have something in Django that does like proper asynchronous support and WebSockets and all that kind of stuff. And sort of sat down there and prototyped it. And the first version was a bit rough and ready, I'll say, but it did a couple of things. Like the idea was it added this asynchronous protocol support to Django. And like it was never about purely WebSockets, but like WebSockets was the important headline, right? So like it did other things too, but the idea was WebSockets was the driving force that people knew about. It was a good buzzword in so many words. But it also did things like background jobs and queuing and other things you want to do, like TCP stuff. That's continued for 2 years, and about 2 years later in 2017, I released Channels 1.0. And that was a continuation of these same ideas. It was very much based on that initial foundation I found for channels back in 2015. Some of those key things were things like being Python 2.7 compatible. At the time, Django was still running on Python 2.7, and I thought it was important to have that as part of the process. Also things like, I used Twisted for web servers because I did want to write my own, and Twisted make a good one. And the crucial thing was I didn't use Python 3, so I couldn't use async IO. So I had to run Django without async support. And so what happened in the old channels was it ran Django synchronously in a separate process and handed things off from a Twisted process. I have got a diagram, don't worry. So basically, you have this separate Django synchronous process, and you have a Twisted asynchronous web server. Twisted is fully asynchronous, it has been for many, many years. And the problem was that these two processes happily live in their own worlds. But how do you talk between them? They are, after all, different processes on the same machine. The reason it's called channels, incidentally, is this thing called the channel layer. If you've ever written something like CSP or Go, which is inspired by CSP's terminology, a channel is a way you send messages from one process to another. And so the channel layer was a thing like, oh, we can use Redis as our thing that lets us do async. And that's sort of the innovation of Channels 1. And of course, diagrams should never have a single thing in them. You say, well, what if I have more than one Django process? Would I get a lot of site load? So the idea was you could have multiple copies of each of these processes handling their various functions. Multiple web servers terminating WebSockets and doing requests. Multiple Django processes doing things like processing model queries and running views, that kind of stuff. And the Redis layer binding them all together. This has a lot of advantages, and crucially, it fits those first three categories. It runs on Python 2, first and foremost. There are, however, some problems with this. First and most importantly, there are too many moving pieces. No one wants to deploy a Redis in the middle of 2 whole parallel sets of extra processes to run their website on. There's just too much. Second, of course, it doesn't have async IO support. That wasn't a problem in 2015. These days, it's much more of a problem. Async IO is much more popular, and people want to use stuff, and there's more libraries that use it. And perhaps most importantly for me, and this is one of the Django philosophies I try to adhere to, it was very, very easy to shoot yourself in the foot. One of Django's core tenets is that we don't only make things that are powerful and useful, but also things that are safe. It's very hard to do the wrong thing in Django, certainly with the out-of-the-box defaults. And unfortunately, Channels 1 was very bad in a lot of ways. For example, it was incredibly easy to deadlock and block the entire synchronous worker. And the conclusion was I was pretty much wrong. Given the constraints of the time, some of it had value. But in the end, I sat back and did some reflection, there we go, there's the word, on my choices, and was like, OK, Let's step back, look at the scenario, look at the environment Python is in now in 2017, and think about this again. But not throw away the lessons of Channels 1. Let's try and bring all the good parts, the design philosophy, the way it's similar to Django, and how do you bring those together? And that's what Channels 2 is. Channels 2 is the culmination of that thought experiment turned into reality, taking the lessons from Channels 1 and the things the Python community has done in the interim 3 years and putting them together. Channels 2 runs on async.io. You can do things using async libraries if you want to. You can run parallel HTTP requests whenever you want to. It runs on Python 3 because these days you should be running on Python 3. If you're not, then I'm sorry, because some of us, and my work is also this case, have some code that runs on Python 2. But if you're doing exciting new things, like asynchronous, like WebSockets, you're probably OK with Python 3. No one's got an enterprise code base they're trying to strap WebSockets onto. And if you are, I'm very sorry. And crucially, it also supports both kinds. It supports both synchronous threads and asynchronous coroutines. I'll get into why it does this later. This is a big important point for me. But I don't think you should be forced to always write asynchronous code. It's much more difficult. So it's crucial to me you could still write boring, predictable synchronous code when you wanted to that was much harder to screw up, much harder to shoot yourself in the foot with. So let's look at some different diagrams how this works. So the first thing that we've done with Channels 2 is we've gone back to the good old single process like WSGI has. There is a web server. Inside that web server, you run Django. It's very happy and familiar. If you want to run more than one web server, you just run more than one web server. The channel layer does reappear. It fulfills a different role here. It's not tying together the different parts of the request and response cycle. Its job is to let you talk between processes easily. It's now a completely optional component. If you don't want it, you can just throw it away and use a database. But often when you're writing WebSocket code or chat code or other sort of similar real-time code, you'll find yourself having this big need for real-time communication between your different processes. So the channel layer is there to give you that common solution to that problem. Like, the Django philosophy is here, we're giving you all the batteries included. The channel layer is the included battery that lets you have that easy-to-use cross-process communication. It's not perfect. It doesn't scale amazingly to huge volumes, but it will get you running for the first 100 requests a second, and then you can start replacing it after that. Now, all of this culminated in around a 75% rewrite of the code base. Obviously, a lot of this is that I went from synchronous Python code to asynchronous Python code. The two are very, very different. Also, Python 2 to Python 3. But the key thing is, when you write async code, they are different to synchronous functions. You can't have a function that's both synchronous and asynchronous. For example, if I've got a function that says, fetch me this model from the database, I can write a synchronous version. If I want an asynchronous version, I need to write a separate copy that's the asynchronous version and call that one. They're two different universes. And you also can't call one from the other. You can't call a synchronous function easily from an asynchronous function. You'll just block the thread. You can't call an asynchronous function from a synchronous function without making an event loop. I'll go through this in a bit, don't worry. It's a bit confusing. But the point being that I had these two different universes. And Django mostly lives in the synchronous universe. It's over 10-year-old code. It comes from the older time of Python when we didn't have proper Unicode support and list comprehensions were new and exciting and all those wonderful things like that. And so I had this challenge of taking Django, which is an amazing code base, very stable, but still has these old design philosophies, and trying to make it partially async. Now, Django is quite complicated. This is a very simplified version of Django, as you can see here. A WSGI handler that turns your request into an object, URL routing that takes the request object and turns it to a function, Django middleware does authentication sessions, views do the logic and presentation, and the ORM does things with models and storage. And the problem is all 5 of these layers are fully synchronous. But if you want to do WebSockets or even asynchronous HTTP, you want some of them to not be synchronous. And so you get this problem where you want to take all of those and add a separate parallel set of versions of them that are asynchronous. And this is what Channels does. Channels has a separate asynchronous set of things that reflect those things in the left-hand column. So you'll see that the handler the one bit of code we can make synchronous and asynchronous at once. So that is the same. But the routing, different versions, asynchronous and synchronous. Middleware, different sets of middleware. Views and consumers, same concept, different universes. And this is the problem that channels faced. This is how it works right now. You get to choose which universe you live in. But the goal is to try and take that synchronous box and slowly but surely move it up to reduce the amount of duplicated code more and more till we share more of the stuff. And eventually take it and have more and more of Django be async native. Now, of course, you'll have heard me say earlier on, but Andrew, you can't call synchronous code from asynchronous code easily. What do I do with all my old nice synchronous view functions? I'm not going to rewrite them to synchronous. Like, no, you shouldn't rewrite them to asynchronous code. And this is the problem. Like, how do you take an existing code base or even an existing set of Python libraries and the ecosystem that's so good? The reason Django is so good is all the stuff out there, and make it compatible with this new system. That is where my two friends, sync to async and async to sync, come in. These are two functions that let you bridge those two worlds. With these functions, you can call a synchronous function from an asynchronous context and vice versa. The name is very self-descriptive. One is easier than the other, so we'll start with the easy one and move on to the hard one. So sync to async. A brief diversion here. When you're trying to run synchronous code in Python, it has to run in its own full thread. And when asynchronous code is running, asynchronous code basically reserves a thread and runs an event loop in that thread. The other threads are free to use if you want to. And so basically, if you want to run a sync function from an asynchronous context, you have to basically make a thread, shove the function in there, run the function in the thread, get the result, and pull it back onto the main thread. And so that's what we do here. This function is pretty much just this code. It's simplified. There's more exception handling. But you use Python's built-in functionality. Like Python core planned this. They knew this would be a problem. And so you can very easily just say, hey, take the synchronous function, run it in a thread executor, give me the result, and await that future. And it will correctly suspend your coroutine, do things in the background thread, and everything runs pretty well. And this is used for a few crucial things. In fact, wherever channels tries to talk to core Django, this is what comes up. For example, if we want to call the ORM, we use sync to async. If you want to render templates, we use it as well. All these parts of Django that have been there for a long time and are still synchronous. Would I like these to be asynchronous? Sure. But I'm not going to rewrite the ORM in a year to be asynchronous. That's not going to happen, trust me. You need much better people than me and much more of them. Or more time, I guess. Like, lock me in a hut for like 3 years, it might happen. And that's not going to happen either. So, like, this is how we mostly use channels. It pretty much lives in front of Django. So whenever you have a request, it hits the asynchronous layer first, does all its stuff asynchronously, and then falls back to synchronous components afterwards. But that's not how all of it works. You have the other problem. Sometimes you want to call asynchronous code from synchronous code. And where this particularly comes into place is when you realize that you want to write, say, an authentication library. Channels has an authentication middleware system that's very similar to Django's but different. And you want to call that authentication middleware from both your synchronous code and your asynchronous code. Because remember, the user is writing code. And as a user of channels, you can choose to write synchronous code and have it easy, or you write asynchronous code and have it more difficult but more powerful. And so we face the problem of like, well, we have to let you call the function from wherever you like, and I don't want to write the function twice. So we have to let you somehow call these asynchronous functions from potentially synchronous code. Now in Python, as I said, asynchronous code runs on what's called an event loop. It basically takes over an entire thread, runs the event loop in the main part of that thread, and it sits there waiting for events. When an event happens, it goes, runs a coroutine for a bit, and comes back again. And so to run asynchronous code, it needs an event loop. You need to find an event loop, give your asynchronous coroutine to it, and say, hey, run this. If you remember, the previous code sample was pretty easy. This is a simplified version of the next piece of code. You're not meant to read this, don't worry. In short, what this is doing is trying to find an event loop. It does two things. If you're running in a thread, it tries to go and find the main thread with its event loop and run it there, which is what you want, ideally. But if you're running in a fully synchronous application, for example, if you are in a manage.py command, you don't have a main loop with an event loop. You're running in a purely synchronous context. So it has to make its own event loop, spin one up from scratch, put it into that, and bring it back again. This is the simplified version of how to do it if you're interested. Now, this is something you should never care about, probably. I mean, you're at this talk, so you care about it somewhat, I'm sure. But the point being, at the end of the day, I don't want my users to worry about this too much. Like, this is a lot of like Python internal stuff. If you want to know the event loop, great. That's lovely. Congratulations. Please come and help. But most people shouldn't have to know that stuff. And so this helps take that idea of having a more abstract interface you can use and make it something like, we can say like, hey, you can write fully async native APIs. Write them once. And if you want synchronous code to use them, you still can. So for example, if you're writing in a channels application, say, hey, I've written an entirely asynchronous native way to query my Redis database and get like current user presence status. It's fantastic. It's very useful. And if you have a couple of management commands you want to use that stuff too, they can just use the same code via these helpers, and you don't have to write a second synchronous stack. For example, in Python, the Redis binding you use for synchronous code is an entirely different package to the one you use for asynchronous code, and they have different APIs and behave differently. Like, it's not just replacing calls. You have to restructure your code entirely to understand how that works. And that's true of a lot of libraries. A lot of asynchronous Python isn't quite the same as synchronous stuff. They're different libraries, they're different calling patterns. And so it's very, very useful to be able to just reuse stuff you've written before. And as I said, you want to write both. As somebody who knows asynchronous programming reasonably well, I will try and never write it if I can. It is so easy to screw up and shoot yourself in the foot that if I can find a very reasonable way to write it synchronously, I am totally going to do that. Because most of the problems in my career have been from writing code that is too complicated and not realizing it, not from writing code that's not efficient enough. If it's not very efficient, you add more servers. That's an easy thing to do. You go into Amazon and press the plus button. That's hard to screw up. If you make it clever and magical, but occasionally it deadlocks and the whole site down, it's harder to fix. And so generally, like, I would encourage most of my colleagues who write code like this too, and anyone out there, write things synchronously first. And when you find a thing that's a particular bottleneck, or if it's just naturally can't be done synchronously, like having to terminate 1,000 people at once, then and only then jump to asynchronous. And this is an important part of channels, right? I want you to be able to take those two worlds and use them when you want to. Crucially, I want you to be able to write views and the rest of your site normally, and then just for the bits that need it, just for like the WebSocket bits or the chat bits or whatever, there you can use asynchronous code. And even then you can use some synchronous stuff, but like use it exactly where and when you want it and when you need that level of power. And you don't use it when you don't need it, and you can be safe and more reasonable. That said, there is one small problem. In fact, on this diagram, there is an arrow right here. This arrow is far too small for the problem it belies. You have all, I presume, heard of WSGI. Put your hands up if you've heard of WSGI, or WSGI, as it's often called. That's like 90% of the room easily. That's good. It is a wonderful protocol we've had in Python for many, many, many years now that standardizes how a web server talks to an application. It's great. It has one small problem. It's fully synchronous. And so you go, OK, well, what if we had a version that wasn't fully synchronous? And this, again, has been argued at length for many, many years on various channels, like, well, we can just make an async def. Like, no, it doesn't work for these reasons. And so eventually, the problem of how do we make WSGI async became a problem for me with channels. And I'm a person who believes in taking feedback to a point and then going away and building the thing, and then coming back and seeing how the thing works in practice. And this is part of the channels 1 to channels 2 thing, right? Like, there are two versions of my approach to replacing WSGI, and I'm much happier with the second one than the first one. So crucially, ASGI, it's WSGI with an A in it. It's a very inventive naming scheme. I'm very proud of this. But crucially, it is a similar replacement for what WSGI does. It lets you have different servers and different applications that can coexist. You don't have to write your application to be against a certain server. When I joined Python, it was a while ago now, and it was back in the days where we hadn't quite got WSGI fully supported yet. It was kind of a new thing. And so some of the old web frameworks were like, well, you have to use this web server for our framework. You can't deploy anything else. And that was like, oh, OK, that's terrible. What if I don't like it? Well, you're screwed. And I didn't want that for this new stuff. I didn't want to say, hey, the only web server you can use is the one that Andrew writes in his spare time. That's not a way to do open source sustainably, trust me. And so having a standard is very important. WSGI is pretty simple. It's a callable that takes an environment. That's basically a load of it's a big dictionary of what happens, like the method and the path, and a callable to start a response. You do your stuff. You start your response with like a 200 OK, then you send some data. It's very simplistic. I wanted a similar thing for ASGI, but it's a bit more of a complex problem. So this is as simple as I managed to get it. It is a callable that returns a callable, which I apologize for, but it has to be like that. But crucially, you can write it as a class. It gets called with the scope, which is like the environment. It tells you what the path is, what the method is, what's happening, where am I, what kind of protocol is this. And then once it's been initialized, you just get called with this call method. You get given two callables, one that sends and one that receives. You sit there, you listen for events on the receive, and then when you get the events, you act on them, and then you send some stuff. And crucially, unlike WSGI, you can't receive more than once here. If an event happens, the only event you have is my function has been called. So you can't have, say, a WebSocket that has like multiple incoming packets. In ASGI, you have that separate receive awaitable, so you can await again and again and again and receive all those events. And that's the crucial design difference between the two of them. The other difference is the wonderful, shall we say, vision we had back in the early WSGI days of WSGI middleware. We were like, well, everyone had, like Django has middleware, the other stuff had middleware, like TurboGears at that point had middleware. What if they could all share the same stuff? And there was a, unfortunately, unsuccessful attempt to do this with WSGI middleware. And being a little bit stubborn, I've come back to that, and doing what's called turtles all the way down. So the way ASGI is designed, it's not just a protocol for talking from a web server into a framework. Every component of channels talks ASGI to each other. The middlewares are just ASGI apps that wrap other ASGI apps. The routing is just an app that takes a dictionary of other apps. It all nests and interweaves in certain ways. You can reuse the channels Django ASGI middleware in the other ASGI frameworks, and it works perfectly fine. Like, that actually does work today. Like, this is the other philosophy of this. Like, because it's much more nestable than WSGI, because it had that sort of, that nice symmetry of send and receive rather than being much more biased in one way, you can nest it much more easily. But crucially, I want to talk at the end here for a little bit, what does this mean for Django? In particular, I showed the diagram earlier of like, there's a synchronous portion and an asynchronous portion. But how much of Django can we make async? How much can we shrink that box and take it from being a huge proportion of Django, being synchronous, to being less and less and less? Can we take the Django routing layer and make that fully asynchronous and reuse it from the synchronous part if we can? Can we take some of the middleware and do this? Can we take some of the view layer? Like, how much can we push that boundary in and then just say, well, if you come in from a WSGI application, we just bridge across to asynchronous and run it in a single thread by itself? It won't perform any worse. It performs the same. And what that means is you can share all that code between two things. Of course, the big elephant in the room here is the top of that chart. What does an asynchronous Django ORM look like? Is it even possible? For many years, this was the thing that scared me the most. I just didn't think this was possible. Thankfully, at a series of conferences this year, I've been very fortunate to have other people in the Python community sit down, talk me through this, and slowly but surely, I think we can do this. Like, I posted a plan to the Django dev mailing list a few months ago with a rough outline of how to do this. The only thing we would lose is magical foreign key jumping when you go like, oh, model.foreignkey.field. You'd have to do select related, which honestly, you should be doing it anyway. So like, this seems possible, right? Like, can we make Django more pluggable? Like, Django has been criticized for many, many years by the rest of the Python web community for being this sort of stalwart monolith. It's very hard to come at Django and reuse parts of it. If you've ever tried to import part of Django outside of Django, you're very familiar with you must configure Django settings module before importing Django. Like this giant trace, like Django requires this like level of setup and like investment that means reusing parts of it is very, very difficult. So it's not just taking like Django itself, but like how do we get the whole Python web ecosystem to this next step? How do we get things like Flask, like Pyramid, like other web frameworks to also make the jump from synchronous to asynchronous? But as part of that, we have to realize something. Most people, by pure number of developers, do not need asynchronous code. If you think you do, you might be right. I'm not here to judge you. But think about it. It's very shiny and exciting, but a lot of normal, boring code is perfectly fine synchronous. We don't need to replace WSGI for a lot of people. It would be much better in the long run. It performs more efficiently, for one. But it's not this really, really important requirement. And one of the things that's very hard to do as an open source project, one of the most dangerous things to do as an open source project, is to impose this kind of restriction. You often see what happens is like people will found an open source project, they will get too buried in the weeds, grow up with it, like, and often this happens a lot with many projects, and myself included. They end up in like bigger companies, they see the big enterprise problems, and like their point of view ends up just being that big enterprise thing of like, well, you know, everyone has these really nasty, gnarly problems. That's not true. Like a lot of, and we saw a survey the other day, like a lot of people here, like this is their first DjangoCon, like they may be like doing small Django websites. One of the key things about Django that I've loved from day one is that you can come in, install it, and run it very quickly. You can get started, and crucially, as you grow, it gets out of your way. Django's strength, rather, is to have this very opinionated framework at the beginning when you are getting started and not sure what to do, or you're a big company and like you can solve your problem, like, hey, but you need the standard. And then as you get bigger, as you realize what your scaling problems are, you can piecemeal take parts of it and remove those and scale them up. And that's kind of what's happened here. The problem is that we can't piecemeal replace WSGI. We have to buy into this wholesale. Since I've launched Channels 2, we now have at least 3 servers. We have at least 3 frameworks to support this. I've had some good talks with other server and framework maintainers, some of whom you'll maintain the big ones. And there's general agreement we need to do this. The problem is getting from wanting to actually having done it. But right now, you can go and run any of these 3 frameworks on any of these 3 servers, and the dream is real. It all runs properly. And in many ways, Daphne, the one I maintain as part of Channels, is probably the worst of these 3, because I'm not really sure what I'm doing, whereas the other 2 have like actual people who are good at their jobs. So in many ways, you want to use those ones. That's part of it. And like, do we want to have everyone writing async, right? And like, I don't think we do, but I think we want everyone to have the option to write async. That's why it's important to me. I think having a Django where we can have everyone have the option to write async, where if you want to, you can go, well, this one view, I want to fetch 5 web pages in parallel, so this one view will be async. That's my dream. I think we should have that. If you want to fetch 25 models in parallel, you can, but you don't have to. I think that's the way to do it. And that kind of comes into, what is Django? Is Django that thing we reached, a few years ago, like it's very stable, it's worked in a certain way, or is Django a place that has to evolve for the next, 5 years of Python? We can't just stand still and do nothing, in my personal opinion. The scene is changing. Like, can we make the Django ORM, arguably its biggest feature, into this amazing async-capable thing that you can use for many years to come? These amazing parallel queries to solve problems at scale that you otherwise wouldn't be able to. Honestly, I think that's what the future of Django is. Thank you very much.